Hi, in this video set we're going to be going over the laser cutter and all the functionality of how you use it. So we'll be going from SolidWorks through to using the laser cutter software to see how to use this. The first part of any laser cutting journey starts usually in CAD. There are other routes to getting it to the laser cutting software other than going through SolidWorks, like I'm going to show you. But yeah, this is probably going to be the one most relevant to engineering majors. So yeah, you have the model. Again, this is going to be given to you. And when you're in SolidWorks, the first thing you're going to actually do once given this model is change the view. You're going to make it view the front portion, such that the Temple T and the Temple University are both visible. Okay. And that's the first thing you want to do. You want to select which face to cut from, usually whenever you're using the laser cutter. Okay, now what we're going to do is we're going to save it as a file type that we can open in AutoCAD, because AutoCAD is the way we need to export it into the slicing software. So we're going to do File, Save As. We're going to do a DXF. Okay, and we're going to hit Save. Yep, I know I've made a million of these. This file is read-only. That's fine. Okay, so save. Yes. Oh, maybe it's open somewhere else. Okay, let's do _1. Okay, there we go. Okay, there we go. Let us do it. Okay, cool. So now we are given where the tree view used to be. We're given, our selection window for the DXF output. And this is usually why I tell you to go and adjust the view initially, and that's because the default setting here is the current view. Okay, so under annotation views, it's under current. A lot of times I forget what is the plane I sketch from, so usually it's just easier to do current. I could also do faces, loops, and edges, which involves selecting a face, but then I would have to go on the inside of the P and the E's and make sure all those were selected too, because it would not select them. So it's largely more work to do it any of the other ways other than what I showed you. I find that to be the smoothest method, but yeah, certain times you might need to use some of those other methods. Okay, so hitting check mark, it should show us this Temple T. It should show us a DXF outline, which is just like the lines of what we want to do. It doesn't really have any depth to it, like our part drawing did in SolidWorks. From this view, from this window, I should say, I can delete or remove entities. Don't really need to do that with this one. We're going to keep this as is. I'm going to hit save. Okay, and then I'm gonna go, let's go to there. And let's go back to downloads. Okay, cool. So we have the _1 Tumble T SolidWorks. Okay, so we're gonna open up that one. All right, cool. So it just showed us, sorry, it just brought us to this new thing that we just made. Whenever you export something from SolidWorks, to like another file format that isn't like a SolidWorks part file, it'll usually put a watermark like that. So we're just going to delete that additional text that we didn't put there, before we cut it out. Okay, so now we have everything that, all the entities that we have created are all these white lines. Okay, we wanted to do different things at different portions of the of the keychain here. Okay, so we want to cut out the outside as well as this hole here. And then what we're going to do is we're going to do two types of engraving for both the Temple University and the Temple T. Okay, so we're going to start by highlighting everything, highlight it all, and then we're going to do 0 mm thickness. Okay, that's usually, whenever you do anything, all like sort of line geometry should be 0 mm. And then we're going to make everything red. Okay, so a note on the different colors and which ones are the correct ones to select. So we're going to be using red for the cut all the way through. Okay, um, the blue is going to be the vector engrave, and the black is going to be the raster engrave. Okay, and we're going to do that on different parts. So the red is the vector cut. Okay, and I'm using specifically this red because it is the index color red. And if you're familiar with RGB, it's the way our eyes kind of work. And because of that, they've made pixels on a screen, have like RGB, red, green, and blue, like kind of light bulbs all really close together, LEDs or whatever. And yeah, it varies the RG and B to give the perception of, a spectrum of colors. Okay, so this red is all red with no green and no blue, and this blue is all blue with no green and no red. And it also uses black, and if you hover over that, it's 0, 0, 0 on the RGB spectrum. So that's like, yeah, so that's like no green, no blue, no red. Anyways, let's make it all red. I'm making it all red not because I want to cut everything through, but it just kind of makes it easier in terms of selecting stuff. So now I'm gonna select, the next thing I'll select is the Temple University. Okay. Well, actually, let's escape so we're not selecting everything. We're gonna select the Temple University. Okay, and we're gonna make this one the vector engrave. Okay, so what exactly do I mean by that? So when it comes to the red, okay, it traces the vectors that you have. Okay, so it literally goes like to whatever power it needs to go to cut all the way through the material, and it just traces out your shape. In this case, it'll go around the outside and trace it out for the cut. And for the Temple University text, if I make it blue, then that means it is a trace engrave. So it's going to literally go along the lines of the Temple University text, and it's going to etch those out at a lower power so that it doesn't cut all the way through. Okay, now the other form, which I mentioned before, is rasterizing. Okay, so that means, so we're going to highlight the temple T and we're going to make that one black. Okay, and black rasterizes. So you might think you don't know you might think you don't know what rasterizing means, but it is what a printer is doing as it's like printing, say, a picture or even a text document. Okay, so as it's making like a text document, right? It's not gonna like draw an A like we draw it with a pencil, right? It's gonna move an inkjet across back and forth, and every time it goes across, it's gonna spit out ink in the exact right spot so that it makes an A layer by layer. Okay. So yeah, it effectively makes an ink blot matrix that to our eyes looks like text that has been, printed, right? So yeah, this type of engrave is a rasterized engrave. Okay, and rasterizing is very powerful because you can do like a grayscale for pictures, and you can do that directly from Word actually, which is quite handy. Okay, to make this a little more interesting, however, we're going to fill in the temple T. So I'm going to go up here to hatch. Okay, so that allows you to fill in, enclosed shapes that you've made with like sketch lines. So we're going to make it solid. We're going to make it, yep, solid. And we're also going to make it 0, 0, 0 black. There we go. And there we go. And there we go. And there we go. Okay, cool. Escape. There we go. Cool. So now we have all the stuff we need to go to the laser cutter. So these are the three colors that it predominantly uses. Again, like it can use a grayscale to do cool rasterizing stuff, but these are the three colors that, do all the different stuff effectively. So now we need to print it, okay? And that involves its own pretty specific, sequence. All right, so we'll do the drop down from the A of AutoCAD, and then we're going to go to print. Okay, so we're clicking print. Now we're going to go and select a printer. All right, so we're going to do the drop down from that guy. BLS 660/75. That is the laser cutter. Okay, pop-up is going to say, hey, this is not like a normal paper size. Is that okay with you? There's a user-defined landscape, and we're going to be okay with that. And as you can see, it's 32 by 18. That is the size of the plotter that we have. Okay. So that's all looking accurate. Okay. And in fact, this hatched pattern is the area it thinks it wants to print. Okay. So let's make sure that is reading correctly. So what I do next is on the what to plot, I'm going to go to window. Okay. And I'm going to outline the figure just barely. Okay, so the reason why I want to be pretty close with this box to the actual size of my part is because that hatched in region on the print preview screen is going to be a representation of my part. So you'll see what I mean in a minute. So again, the box is very close to the size of the part. Clicking there. Now you see that hatched in box is like much smaller now, but it is still kind of hanging off the page. So what I always do is go to center plot. Okay, cool. Now it's in the middle, but this looks really big now, right? So this looks like it's, I don't know, roughly 6 inches by 6 inches, maybe 7 by 7 or something like that. It's really big, or even bigger than that. Maybe it's even 8 by 8. Whatever. It's too big to fit in your pocket. It's not a keychain size. So that's not the size that it was intended to be. And you can see down here that it is doing some scaling. All right. So instead of a custom scale, we're going to do a 1-to-1 scale. Okay, now you can see it looks a little bit more accurately keychain size. Okay, and we got to make sure we're in inches. That's the unit this part was designed in. So if you design it in inches, make sure it's in inches in SolidWorks, and then go to inches in AutoCAD, and then make sure it's expecting inches as you get to the laser cutter. Then everything is good, and vice versa with millimeters as well. So as long as you stay consistent, everything should be just fine. Okay, so we're going to click OK. All right, great. So it looks like it hasn't done anything. Obviously, nothing's going to print directly. So from here, we're going to type in to the start menu UCP, and it's going to pull up this desktop app. Click click on it, and we see our image has been transferred to this app. Okay, so just going to go over the functionality of what you can do in here. First thing I'll talk about is, we prefer that you turn on and off the machine from the app, and there would normally be a play, or sorry, a power icon over where my mouse is right now. So normally I do that first, but since I'm at home right now, I'm not able to plug into the machine. So we're just going to do everything apart from that. Okay, so first little button here is our zoom button. Very simply, left click, zooms in, right click, zooms out over where the little icon is, over where the magnifying glass icon is. Pretty standard. This next one here moves the turret, or sorry, the head. So where the laser beam comes out and hits your part. So right now it's not going to do anything because obviously it's not connected to the machine, but I can move this wherever I might want it to. And indeed, later on in the video, you'll see I'll use this to move the head around so that I can do things like take the lens out and set the zero height. Next one over, so the third one will allow us to move this guy around. Okay, and put it anywhere we want, wherever we decide to put our material on this plot area. Okay, now fourth one over, we could make a matrix of these, make a 3 by 3 or whatever we decide to do. We're just going to do 1 by 1. Okay, and this fourth one over here gives you a time estimate. So let's do that after we set some of our settings, or else this is going to be slightly inaccurate. Okay, so go into settings. We are going to go to, so I'll give you two options. You could either do the wood, which is basswood, or the acrylic. So I'll talk about both of those here. But for the wood, you do the drop down from natural, and then you do wood, and then you do medium wood and general medium wood. So I know that was a journey. So let's go back through that. So drop down from natural, drop down from wood, and drop down from medium wood, and then finally general medium woods. Okay. Now the thickness of this is 0.1875, which is 3/16. But I usually just make it zero point 0.2, and that's roughly 10 thousandths oversized. So yeah, increasing that a little bit just hopefully ensures that it cuts all the way through. I also put the throughput to 2, and I also increase the vector cutting upwards of 10 to 15%. Okay. And as the laser sort of gets older, we have to increase the vector cutting intensity up from where these preset values are. And yeah, these are preset values, so I don't know offhand like how much laser intensity or the combination of laser intensity and feed rate that it's using here. But yeah, we have these are pretty good presets, and we modify them slightly to work best with our with what we're doing. Okay, so I'm gonna do that. I will cut wood, but let me show you the other very common one we have would be would be with acrylic. So with that one, you could go from a plastic, and then you do acrylic, and then you want to do continuous cast acrylic. Okay, extruded acrylic is kind of harder to cut through. And if you do end up buying extruded acrylic, usually you'll have kind of bad results, but the cast acrylic stuff will cut quite well. Okay. And again, with this, I would increase everything past what it was. But yeah, let's go back to the wood because that'll be the one that we'll be messing with. So we go to, where is it? Natural. Do the drop down from natural, wood, and then medium wood. Oh, yeah, medium wood, general medium wood. And we're gonna make this 0.2. And we're gonna make this one throughput 2 and 15% apply. Okay. All right, cool. So yeah, now we can finally do an estimate and we can see how long it's gonna take. 2 minutes and 19 seconds. Okay, cool. So yeah, that is pretty much it. And now we'll cut to setting the machine up. All right, so we have a couple things here that we're gonna arrange as far as our the physical settings of our cutter is concerned. So what I've done is I moved the cutter somewhere in the middle of the machine, okay? And I'm gonna place our material up under it. All right. The first thing I'm gonna do is I'm gonna take off this these 3 bolts, which will allow me to remove the lens. Okay, so this is the laser lens that we're gonna be using. As you can see, this is a 2.0 lens. All right, and that has to do with its focal length, which we will set in a minute. But as you can see, is it has a mirror here and a lens there that focuses it. And over in here, in this little box here, there is also another mirror. So the laser will come out of this hole that I'm pointing at, go into that mirror, and hit this other mirror and lens, and then finally go into your part. So the laser itself is not moving, but a system of mirrors are moving in order to move the beam to where it needs to cut. Okay, so what we're going to do with this is actually clean it before we use it. So we're going to grab some of our optical tissue here. So we're going to rip out a page. I usually like to fold it in quarters. And then what we're going to do is use a little bit of our lens cleaner. Okay, so just get a little bit of lens cleaner on there. And then what we're going to do is we're going to clean the different lenses. So we're going to clean the lenses and the mirror as well. And then I usually like to quickly dry them so that you don't get any residue or anything like that. And make sure that they're all smudge free and looking pretty clean. That looks fine. The reason you clean it is because whenever you cut with the laser cutter, you have to whenever you cut with the laser cutter, there's a lot of solid particulate in the smoke that comes up that can get deposited onto our lens and our mirror, and that can ruin them. All right, cool. So now that we have that clean, what I'm going to do next is we're going to set the focal length or the height. Okay, so basically what we want to do for this one is set the focal length right on the top of the material here. Okay, so what we're going to do is actually use this stock. So if you see, this stock has this little notch. Okay, that little notch is going to line up with the bottom. I'll just take this out once more so you can see where it's lining up to. So it's going to line up, as when this is on here at least, it's going to line up with this little edge. Okay, so that very edge there, which is kind of like that, same as that edge there. Okay, so we're going to hit it up. We're going to hit that edge to this guy here, and that's what we're going to call our focal length. So we're going to stick this back in here. All right. I'm going to tighten this up here. Okay. Like I'm doing before. Okay. Now this is kind of out of shot, but it's going to be helpful so that you see what's happening. Basically, we have a Z or a table height adjustment. So that's a Z. Basically, there are a couple buttons on the machine with a Z and an up and a down. So what I'm going to do is I'm going to bring this guy all the way down. Okay. I'm going to bring it down such that the little notch is below the lip. Okay. And then what I'm going to do is I'm going to set it up against there so the flat portion is up against, the flat portion of our probe here is up against the bottom there. Okay, so now what I'm going to do is actually I'm going to zoom us in here so that you can see what I'm talking about. But what we're going to do here is we're going to incrementally move it up until we see that little stick. You see that? It was very subtle. So if I do that again, you see how it moved very slightly away from the part, or from this face here. So at the point it moves very slightly, you'll see it even moves even more as we go up farther. Okay, but what I do is I'll do it one more time. So I'm going up, 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 and it kicks itself out. Okay, I want to go back down one more time, and that is what we are going to call the focal distance. Now, with certain parts, so certainly with parts that I'm only cutting, I will sometimes put the focal length somewhere in the material. So I'll get it a little bit closer than I have it now. But since we're going to be rasterizing and engraving, that's where I want to cut it. Okay. Now what I'm going to do out of shot is go over and move the head around to see where we're actually going to be cutting. So I'm going to move the head around to where the part is. Okay, cool. So that you can see the laser is on the part right now, or is on the material. That's good. And I'm going to also move it over here. Okay, and it does look like we're just going to be barely off the material. All right, so what I'm going to do is actually move the material around a little bit. A lot of times I don't have it directly in the middle like this, but it's kind of going to be better so that you can see it on camera. And actually I'm going to move in the software, I'm going to move the keychain around just a little bit, and we're going to double check that it'll cut on the material. So again, I'm going to go in the upper left-hand corner. Okay, let's move that. We'll just move the material over. So there we go. That's the upper left-hand corner. And now we'll go to the lower right-hand corner of the part. Okay, cool. So we're definitely fully on the part there. So now there's only one more step, and that is to set up the ventilation. Okay, so we're right beside the machine now, and we want to set up how we ventilate the machine. So yeah, you want to be really careful when it comes to laser cutting. You don't ever want to run this without the ventilation for both your safety and the machine's safety. Okay, so what we're going to do first is we're going to turn on our BOFA unit. Okay, so we turn that on, and as you can see, it's powering up, and it's all green, so that looks fine. Now what we're going to do is also turn this valve. So if I turn that valve, okay, that sends air through the nozzle, okay? And what I want to do is come down to this little dial here, okay? And just make sure I'm at about 15 psi. Okay, cool. We look good there. And then now what I'm going to do is just double check over here that I feel some air coming out of the nozzle. Okay, I definitely do. And that's a good indicator. So that means any sort of smoke that comes up from the cut is going to get pushed away from the nozzle, and hopefully it won't get into our lens or our mirror. All right, now with everything ready, with all the ventilation on and everything like that, and all the settings prepped, we could finally run our part. All right, as you can see now, it's doing the rasterizing step. So this is what I meant before when I described rasterizing. It's going back and forth and only pulsing the laser where it needs to cut. So, you know, right now it's only doing the small ends, and yeah, now it's got like 4, you know, pulses that it's going to do for a certain amount of time. And yeah, obviously it knows what it needs to do, and it'll go back and forth and rasterize that whole image. You can also zoom you in here so you see it a little bit better. Cool, now it's almost done with the T. Almost done with the T, and then I think next it'll go on to the vector engraving. There we go. So now it's going to do the Temple University. It should be noted that I'm not staring at the laser. This is kind of a powerful laser. It's probably not the most dangerous laser in the building, but you know, it's an infrared laser, so it's not something you want to be staring at. It's definitely something that, you know, you want to be monitoring. Certainly you want to make sure that if there is like a fire that's starting in the laser cutter, that, you know, it's that you're going to notice it, okay? But yeah, I'm going to make sure that I don't look directly at it. Right now I'm looking at it through the lens of the camera, which is kind of helpful because I get to watch the whole thing. All right, so let's take a look at our part, and hopefully we have cut through the entire thing. Yes, it looks like we have. All right, so there's our Temple T, and that's what you guys are going to be making when you come to class.